All right, so the midterm was yesterday. I hope the midterm went well. It seems like the midterm maybe went either too well or too poorly because there's no one in the room. But um, so if you're watching on video, today we're gonna do a lot of pointer traces, okay? Um, oh, just a couple announcements. So assignment 5 is released today. I personally feel like assignment 5 is one of the tougher assignments, so I strongly suggest getting started on it early. Okay, let's see. Midterm grading is happening this weekend, so you can expect to get midterm results back sometime on Sunday or Monday. If you ever want to chat with me about like how you did on the midterm, what areas you can improve before the final, send me an email and I will we can chat about it. Okay. All right. Let's get started. So today we're just going to do some trace questions. The trace questions we're going to do are pointer related. So, hi, CS106B? CS106B? Section?
Just.
Yeah, feel free to take a seat, yeah. Okay, all right, so let's get started. We're going to do a trace question. This is number 2 on the handout. This is a pretty intense and crazy question, so we're going to do it step by step just to make sure we get every detail, okay? As you can see here, I spent like a few minutes drawing this out here. This will be our very first line of code, so just didn't want to draw it on video, but there it is, okay? So before we begin, let's talk about the stack and the heap. So the stack and the heap, they're different areas of memory. The stack is automatically managed by your system you're running, so you don't have to worry about like memory management here. Any memory you declare on the stack is automatically freed and managed for you. Now, heap memory, you can specifically ask for heap memory by calling the operator new, but when you do that, the memory that it gives you, it persists even beyond the end of your function. So you have to make sure to free this memory yourself. Okay, not doing so is called a memory leak. All right, so let's get started. We're gonna do number 2, and this question starts by calling the function Gryffindor. All right, so when a function is called, we create a new stack frame for it. So let's see, Gryffindor. Okay, when we call this function, it allocates like some amount of memory for the variables in that function. The first thing we do is we create a pointer, Hogwarts. Okay. So this is the type of that pointer. Hogwarts star, it means the star means it's a pointer, and Hogwarts means it's a pointer to a Hogwarts struct. Okay, you can see on the page that the Hogwarts struct is defined over there, and you can see we're going to create an array of Hogwarts structs. Now the first thing to note is in the line Hogwarts. Let's see. Let me write it out here. Hogwarts star try wizard is equal to new Hogwarts. What this line of code does is, first note that we're calling the new operator, which means we are asking for memory on the heap, which is why we drew this thing that we're going to use on the heap. Now, we know specifically this is an array because we see that Hogwarts is followed by this bracket 3. This means we're creating an array of 3 Hogwarts structs, okay? Which, if you look over there, is what we are doing. And then finally, when you call new Hogwarts, this thing returns the address of the first element that in your array, okay? So in this array, let's call this memory location 0xff00, which means that this thing, since the first address has 0xff, it returns 0xff00. All right, now, after we're done with this line, we can look at this part over here. This is declaring a pointer. Now, this is declaring a pointer on the stack because notice that this variable try wizard over here is not created using new. Okay, this is created using new. This part is creating the array, but this pointer, this is a pointer, is not created on the array. So this is created on the stack. Hogwarts try wizard. This variable is on the stack, and we're gonna give it the value 0xff00. Okay? So remember, this is the Hogwarts array, and it's we're give it the address 0xff00. All right. All right. So now that we're done with that, this is pointing to this thing over here. I know some instructors like to draw arrows. So some instructors like to draw like an arrow like that. I personally don't like arrows because we're going to be doing a lot of arrows on this diagram. So if we draw any arrows, it's kind of confusing. Okay? I personally just prefer to write the pointer as an address. Now, later on when we get to linked lists, it makes a little more sense to draw as the arrows, so you can actually see a list forming. But in this example, we're just going to use the address. All right, so let's see. Try wizard bracket 1 equals wizard. Try wizard bracket 1 dot wizard equals 3. What that line does, let me just write it out. All right, first thing to note is try wizard is a pointer. When you try to call it using the array notation, what it does is it looks at 0xff, it goes to that array that it's referring to, and then it's specifically taking out the first element. Okay, so this part you see over here, this thing, let's use a smiley face. This thing is referring to this thing over here, smiley face. Okay, try wizard bracket 1, that's referring to this entire struct. And it's getting the entire struct, not a pointer to the struct, it's getting the entire struct. All right, does this make sense? Okay, and then we're using the dot operator over here. Okay, remember that when you have an actual object, like not a pointer, but the actual object itself, using the dot operator allows you to access a certain field within it. Okay, so we're taking this object and we're saying dot wizard, so we're specifically referring to this red box over here, this wizard variable. Okay, all of these variables are currently not initialized, so we're going to leave them blank. They might have some like value to them, but that value is not guaranteed. It's like garbage uninitialized value, so we're just going to leave it blank for now. But here specifically, we're taking that red box and we're setting it equal to value 3. So I'm just going to go over here and write 3. Okay? And similarly for the next line, the third line, we're doing the same object, but instead we're setting dot potter. So if we go over here, we go to dot potter over here, and we're setting that to null. All right? Right? In modern C++, rather than using null, we like to use null pointer. So I personally prefer to just put null pointer here. Okay? I pronounce this null pointer, but I know most people do null pointer. Now, null pointer is essentially saying, oh, this is not pointing to anything. Null pointer has value 0. There's no address at 0. Okay, let's keep going. So try wizard bracket 1, try wizard bracket 1 dot potter equals null. That's the line over there. Next, we're going to do try wizard 0 equals try wizard 1. Try wizard 0 equals try wizard. Okay. These two are the actual objects themselves. Try wizard 0 is this one. Try wizard 1 is this one. And here we're setting try wizard 0, this thing, to equal this one. All right. Now notice that when we set them equal, what happens is we copy everything here onto index 0. So what happens is we copy the 3 over here and we copy the null pointer down here. Okay. This is important. These are actual objects themselves. They're not pointers. All right. If you set 2 pointers equal to each other, that doesn't make the thing they're pointing to equal. That doesn't make the the objects themselves equal. That makes the pointers point to the same thing. But here, because these are the actual objects themselves, it is copying whatever's at index 1 into index 0. Does that make sense? All right. Try wizard 0. Okay. Now, the next line, let's look at the next line. Try wizard 2 potter. I'm not going to write it out because we're going to call the Hufflepuff function. So essentially, we have to first call the Hufflepuff function. Then we pass, when we set try wizard 2 dot potter equal to whatever that function returns. So let's call that function. Actually, oh, we can't move this. Okay. So Hufflepuff. Now, inside this Hufflepuff function, we pass in a parameter, and that parameter has type Hogwarts star. It's a pointer to a Hogwarts struct. It has name Cedric, And specifically what value we're passing? Well, we're passing in try-wizard. Try-wizard has value 0xff00. So here we also pass in 0xff00. Okay? Notice that this, when you're passing pointers into parameters, they're passed by value, unless you specifically put the ampersand. Then they would be passed by reference. But here, we're making it pass by value. So we create a separate copy of the variable. Any change you make to this one does not impact that one. Does that make sense? All right. Now let's go, let me erase this, because let's go to the next slide. All right, now this is getting a little confusing. So let's take this step by step. Quidditch star seeker, that's equal to ampersand Cedric arrow Harry. Okay, so we start by looking at the right-hand side. We see Cedric arrow Harry. All right, the arrow operator means we are dereferencing and then accessing a member. Right? Remember from before that when we wanted to access like a certain struct, if you have the actual object itself, you can use the dot operator to get like a certain value in there. Like what we did before, we used the dot operator. But here, because Cedric itself is a pointer, you have to first dereference that pointer. So 0xff, we have to dereference that pointer to get to this. When you dereference the pointer over here, you get the first value over here. And then what the arrow operator does is it not only dereferences, but it also gives you the field that you want. So here we want the field Harry, which is, let's see, where's Harry? Oh, the Quidditch itself is called Harry. Let me write that in there. This Quidditch is called Harry. Harry. All right, so this thing, which I'm gonna put a star, this thing inside here, it's referring to this star. Okay, remember that the arrow operator is equivalent to this, Cedric, and then dot Harry. All right, we're saying take Cedric, dereference it, so we get this struct, and then access the dot Harry field, so which is this entire orange thing. Okay. All right, let's see. Now, notice how we put the ampersand. When we put an ampersand in front of some variable, we're finding what the address of that variable is. So here we're saying, okay, what is the address of orange star? We haven't given it any address yet, so let's just say, for example, it has address 0xff88. Okay, so this orange thing has address 0xff88. So this thing is now 0xff88. Right, we're saying what the address of the thing in star is, and that's 0xff88. Right. And then we set this thing to seeker. Since seeker is not declared using new, this pointer is on the stack. And let's write it over here. Quidditch star seeker. And it has value 0xff88. This seeker is a pointer to this struct. Not the whole thing, but only this orange struct. All right, any questions at this point? All right, so next line. Seeker arrow snitch is equal to new. I think it's easier if I just write it out. Seeker arrow snitch, that's equal to new int. So of course you start with the right hand side, new int. We're using the new operator, so that creates an int on the heap. And then remember that new returns the address of it, so let's call this 0xAA00. Okay, so new returns the address 0xAA00, and then we're going to store that inside sneaker arrow snitch. Let's remember what the arrow does again. The arrow first takes the address, it dereferences it. So if we dereference 0xFF88, we get the orange. So we get the orange. Let's put the star. And then we're saying dot. the arrow operator first dereferences, then it accesses the members, the field inside. So here we're saying star, which gives us the orange one, dot snitch, which is the field we want. We're setting this thing equal to 0xAA00. Okay? Yeah, just don't remember that what the arrow does is it is dereferencing. So here, when we dereference seeker, we get the star. Then it accesses the member of whatever you just dereferenced. So here we're setting the star dot snitch. So we're setting this thing over here to equal 0xAA00. Let me write that out. 0xAA00. Let's see. Okay. All right. Next line. Also similar, a similar line. We're setting star seeker snitch equal to 2. Let me erase the first 2 lines. So remember that star means you dereference a pointer. Seeker arrow snitch is saying seeker, you dereference seeker to go to 0xFF88, this orange thing. We're accessing the field snitch. So we are getting this thing over here, 0xAA00, and then we dereference 0xAA00. So if we dereference 0xAA00, we should go to 0xAA00, which is over here. And we're saying set that entire expression. Let me just call this sad face. This thing is now sad face. Okay? This thing inside is 0x AA00. Okay? 0xAA00, that is this pointer over here, seeker snitch. And then we're dereferencing it, which to get the integer below, the sad face, set that equal to 2. So we're setting this thing equal to 2. All right? Okay. Next is probably the most challenging line of the entire program, trace. So let's follow it carefully. Cedric equals new Hogwarts. Okay, let's trace through what happens through this. First, we look at new Hogwarts. We're declaring a new Hogwarts. We're using the keyword new, which means we are creating this new Hogwarts on the heap. We don't use the bracket notation, which means we're just creating one. I don't have room down here, so let me quickly pull this up. Okay, let me write a new one over here. Okay, these are not related, but here is another Hogwarts struct. A few seconds while I quickly write it. Wizard is equal to that. Quidditch. Harry. Quaffle. And star snitch. And bludger, which is an array of size 2. 0, 1. Finally, we have a Quidditch pointer. Quidditch. Potter. Okay? Now, so that's what this does. Let's call this at location 0xCC00. So new creates the new struct over there, and it sets this thing to 0xCC00. All right? Okay, and then we're setting Cedric equal to that. What does that mean? Well, Cedric itself is this pointer. And since we're setting Cedric equal to this address, it's taking, okay, change this variable and make it so that its value is now 0xCC00. Right, this line is very confusing because some students think, oh, now I changed this one. What about this one up here, since we passed try wizard in here? Remember that when we pass parameters, if you're passing a parameter, a pointer as a parameter, by default it is passed by value. So that means we create a separate copy of it. Any change you make here does not persist up there. So when you change this pointer, it doesn't change any objects. We're just changing the Cedric variable itself. All right. Any questions? Okay. Let's keep going. Let's see. Seeker, snitch to Cedric. Okay. Cedric, arrow. Cedric, arrow, Harry, dot, quaffle. Okay, this line looks really confusing as well. Let's trace it one more time. Cedric, arrow, Harry. That means you dereference Cedric and access the Harry field. Dereference Cedric. So if you dereference Cedric, you get 0xcc00. So we're going to this one over here, and we're going to access the Harry field, which is orange. Okay. Let me call this double star. So this orange thing over here is the same as this orange thing over here, double star. Okay. Now we're saying double star dot quaffle. So we're saying this thing over here access the quaffle field, and we're setting that equal to 6. All right. Next, Cedric, arrow, Potter is equal to seeker. So same thing again, seeker. All right, so this thing, let's just use triangle. Cedric, arrow, Potter. Well, Cedric, if we dereference Cedric, 0xcc, we go over here. And then we want the Potter field, which is this one, and we set that to seeker. Now what's seeker? Seeker is right now 0xff88. That's the variable there in blue, so we're setting this to 0xff88. All right, we're just going line by line here. These trace questions are really confusing if you try to skip any lines, so we're just going to go step by step and try to see what is happening. All right, Cedric, arrow, Potter, arrow, quaffle. Cedric, arrow, Potter, arrow, quaffle. And we're going to set that equal to 8. All right, let's remember what this means. We said above Cedric, arrow, Potter is triangle. Oh, I never put this as a triangle. This is triangle. And we're going to say that arrow quaffle. So remember arrow again, which means we dereference the triangle, and then we access the quaffle field. So if we dereference this 0xff88, we get 0xff88, this struct over here. And we want the quaffle field, so that gives us this one over here. Let me reuse some of these because we don't need these anymore. Okay, so no more sad face, no more of that. Let's call this one, let's just call it circle. So this whole thing over here is referring to circle because triangle, if we dereference triangle, we get, this star. And then if we take the star, we want to get the quaffle field, which is this, which is circle. Okay? All right, let's go. Okay, this line looks very confusing. Let's be very careful here. This next line is Cedric, arrow, Potter, arrow, snitch, and that's equal to ampersand, Cedric, arrow, Potter, arrow, bludger. 1. Okay, let's parse through this step by step by step. Cedric, arrow, Potter, that's the same thing we did before. Cedric, dereference Cedric. You get here, we access the Potter field, that's triangle. So this part is triangle. Now we're saying we dereference triangle and we get the bludger field. So dereference triangle, 0xff88, that's this one, and we get the bludger field, which is this thing down here. And specifically, you want the, let's see, this, specifically it's the bludger field, the first element of the bludger field. So that is, let's use purple. Okay, let's use double circle. Okay, so this whole thing is referring to double circle. And then we're saying we want the address of double circle. We don't have an address for that yet, so let's just give it 0xff99. Okay, So this whole thing is equal to 0xFF99. All right. So we know we're setting something to that. Let's see what we're setting. We're setting Cedric.pattern, so that's triangle again. Cedric.pattern is triangle over there, and we're getting the snitch field after dereferencing. So 0xFF88 dereference, we get this one over here. That's yellow, orange star, and then we want the snitch field, which is this one. Okay, and we're setting that equal to 0xFF99. So let's set this thing equal to 0xFF99. Okay. Let's slightly change this a little because, let's just keep it that way. Okay. So this is, the whole thing is at address 0xFF88, but this inside here contains 0xFF99. So this is a pointer, snitch is a pointer to the first element here. If you were to draw this graphically, it would look like an arrow from here pointing to here. All right, wow, this is a long question. Okay, seeker, bludger 0 equals 4. We're almost there. Let's erase this line. Seeker, bludger 0, that's equal to 4. So let's just trace this one more time. Seeker, which is seeker over here. We're dereferencing it, and we're getting the bludger field. Seeker, dereference, we get the orange star, and then we're getting the 0th one. So this one over here. I'm out of colors. Let's use this light blue, light green, bluish color. This one, let's call it neutral face. Okay, so this thing is referring to neutral face. And we're setting that thing equal to 4. So we just go over here and we set that to 4. Okay? Then we return seeker. So we return 0xFF88. Okay. Let's return 0xFF88 to the function that was calling, to the function call. Now the function call was, let's see, try wizard 2.potter. Set that equal to the function call, Hufflepuff try wizard. So this thing returned seeker, which was 0xFF88. After we're done with that return type, this function call doesn't exist anymore, so we can just this is now gone. And then we're going to set try wizard 2.potter equal to that. So try wizard 2, that gives us this struct over here. Potter gives us .potter. So that's this green thing over here, and we're going to set that to 0xFF88. Okay? All right, last step. Still try wizard 2.potter. But now we're dereferencing that. We're going to get quaffle, and we're going to set that to 4. Let me call this thing up here. Let's give it one more shape, square. So this thing down here, this is square. Okay? So square, we're going to set square equal to 0xFF88. Now we're taking square, and we're going to dereference square, access the quaffle field. So dereference square, 0xFF88, that's orange again. And we're going to access the quaffle field. Quaffle field is this one. So this one is actually blue. Now we're going full circle. Now we're back at blue. And we're going to set that equal to 4. So set that equal to 4. All right, let me double check the answer just to make sure out of all this, the answer is correct. Let's see. In the end, this should no longer exist. And these are just instructions. Let's see, 0xFF88. This one is pointing to the first element. And this is 3, 4. Snitch is pointing to this one. 4 is here. These are null pointers. This is 3. Nothing else. This one is pointing to 0xFF88. And we know that. Oh, yeah. So let's think about what happened to this one. Okay? It might make more sense to let's now draw the arrows. Doing the actual trace, it's hard to actually draw the arrows. But now let's actually draw the arrows, see what happens. So this one 0xff. 0, 0 is pointing to here. All right. Let's remove the stars, all these shapes. Okay. Now, the orange, 0xff99, this one is pointing to here. These are null pointers. Null pointers, we usually just represent them like this. 0x, this thing down here, this square, 0xff88, this is referring to orange. So let's use blue. This is referring to orange. Let's see, 0xff88, this is also referring to orange. No more triangle. And I think that's it, okay? So now we don't have, now instead of writing the memory addresses as the pointers, we're instead just drawing out the pointers themselves. Let's see. Now let's think about what happened over here, right? Notice that there's nothing on the stack, or there's no way we can start from the stack and access that one anymore, right? We can start from the stack and access any one of these, but we can't access that one. So we call this a memory leak, where you essentially forgot to clear that memory, okay? So once you don't have a pointer to it anymore, you can never retrieve it back again. Okay, so something that you probably want to do is before the Hufflepuff function returns, you should probably clear, was it Cedric? Yeah, Cedric before was pointing to that one. You don't want to add a line, delete Cedric, which would clear that memory overlay. Okay, that's called a memory leak. On some diagrams you might see, we call this thing orphaned. Okay, and we also call this thing orphaned. Yeah, notice that there's no, this integer is also lost. On the solutions, it doesn't show these two, but these two are, oh yeah, okay, no, these two are shown. That one is like, this one is drawn here instead, but that one is shown except it's orphaned. This 2 is also shown, it's also orphaned. Okay? All right, and here we go. This is a full pointer trace question. Now, pointer traces are going to appear on the exam, but they're definitely going to be shorter than this. Okay. Okay, let's do a question. Let's do this thing called stretch. Let's do a question called stretch. All right. So this stretch question, this is number 3. This is going to be really relevant to what you're going to do on the assignment. Okay. And I think you did something similar during lecture. The question is essentially, okay, we're going to deal with that array int class again. We wrote a class which stored a bunch of ints, and it would, before it had the array, let's say this array had the elements 18, 7, 4, 4, 24, 11. Okay, and then we want to stretch it. If we call list.stretch, list.stretch 3, then what it does is it replaces each one with 3 copies of itself. So 18, 18, 18, 7, 7, 7, 4, 4, 4 for the first 4, 4, 4, 4 for the second 4, 24, 24, 24, and 11, 11, 11. Okay? So by stretching this one, you get that one. And this all happens in our array, okay? So someone else using your class is going to create a list of that, stretch it, and then when it tries to access the elements of the list, you get a stretched version. All right? All right, if k is less than or equal to 0, the list should be empty after the call. Okay, do not call any of the member functions. Don't make assumptions. Okay, so let's start by looking at what the function we have to write. So usually I'd ask for pseudocode, but there's no students here. So let's just go through the pseudocode. You should pause the video, try to think about how you would do this question. Some pseudocode. Okay. So the idea is our array right now, we don't actually know like its size. So there's two concepts to think about. One is called size, one is called capacity. Let's say our array currently looked like this: 18, 7, nope, 7, yeah, 7, 4, 4, 24, 11. Recall from lecture that we stored like internally we stored the elements as like an array. And then there's two concepts to remember. One is called capacity. We're storing this this member variable called capacity, which is essentially the number of the largest possible size in your array. Right now it's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 7, 8. Okay? While the size, or my size, that is the actual number of elements in your array int list, which would be 6. Okay? So here capacity is equal to 8, but size is equal to 6. They're different things. Capacity is if the array weren't, if we didn't change the size of the array, what's the maximum number of elements it could hold? My size is how many elements does it actually hold, okay? We don't actually know what is in here. Could be initialized, could be garbage. We just can't access those values, okay? Now, we're storing this array where this is another, is it elums? Elements. Okay, this is an array that we're storing using instance variables. This is also like a member variable, it's elements. Okay, inside our class, we can use these three freely. All right, so the thing is we want to expand, we want to stretch this array. A couple things we have to think about. All right, first is if the value of k is less than 0, if k is less than or equal to 0, then according to the handout, it says we should, our array int list should be empty. So we should just empty the entire list, empty list. Okay, we'll worry about how to do that exactly next. Now, let's see, second part. If k is greater than 0, on the handout, if k is greater, not this one. If k is greater than 0, then what we would do is we would, let's see, elements, not two size. Yeah. So, okay, if k is greater than 0, then we have to essentially stretch the elements. Okay. First thing to note is if we tried stretching the elements right now, our array is currently too small. Okay. So we have to figure out if we have to resize. Else, if the array is too small, if array is too small for stretch, then we have to stretch the array. We have to, you can't resize an array, so the only thing you can do is you have to create an entirely new array, copy all the elements over. Okay, so we have to create new array, copy elements over, and then make sure you switch the pointer. So we have to make sure this element is now pointing to your new stretched array. Okay, all right. So that's if the array is too small. But notice that after we copied the elements over, let's say we copied, there's a gigantic array. We're going to stretch it somehow. And then after stretching, our element still looks like this. All right. So well, one thing we definitely want to do is we want to essentially stretch the array over. We want to move the 11 out, 3 copies out here. 24, 24, 24. Too many elements. Let's remove a few elements from our example. Otherwise, this board won't fit. Let's say we only had 4 elements. So 24, 11. Just for the sake of time, let's make it fewer elements. In which case, here you need to stretch the elements so that to make sure they have 3 copies of each. Right? It's hard to do it in place because you don't want to create another array and then copy them one by one. So the other thing you could do is you could start from the back and copy them one by one like this. So you do something like, let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay? So after stretching to however large, some size, then we want to essentially just shift them all up. So we know that this one, 3, the element at index 3 should go to 3 times the amount it's stretched, 3 times k, and then plus either 0, 1, or 2, right? Here we want to stretch to 0, 3 times k plus 1, and 3 times k plus 2. Okay, k here is 3, so we stretch it up to, we want to put it at indices, let's see, 11, 11, 11. Okay, same here for the 2. Instead of 3, we put 2 over here, so this is index times 3, so we put 3 over here, 24, 24, 24. Then we can slowly go backwards. We can go backwards and put the elements there. So now we go to the 7, 7, 7, and because we had already written 11, we can safely overwrite this 7. Finally, 18, overwrite this 18, 18. Okay? So the idea is we will have to start from the back and move the elements, stretch them across so that by the time you have to overwrite some of these, you will have already processed those, so you can safely overwrite them. All right, so switch. So here, let's finish our pseudocode. This is only if the array is too small, but in either case, you have to perform this operation. All right, here we'd say, okay, we want to start from the back. So for size minus 1, for I in size minus 1, all the way to 0. Okay, so here we started from 4 and we was 3 and went all the way to 0. We want to essentially copy these elements one by one. Okay, here it's only 0 to 2 because we have k is equal to 3. But if you have more, you should go from 0 up to k minus 1. So here we should say, okay, for j in let's say from 0 all the way up to k minus 1. What you should do is you should copy the elements one by one over. So I just say copy copy, let's say we have to copy the element at index I, copy the old element at index I, old at index I, and we want to copy it to the new array at index. It's the index I here times k plus 0 all the way up to k minus 1, which would just be j. Okay. Copy all the elements over, and then we've made sure we're done. Okay. Oh, we don't need old and new array because we are operating on the same array. We're doing it in place. Because we're doing it in place, we don't have like separate arrays. We're taking one array and we're just doing it in place, stretching all the elements across. So these are just the new array. Just the array. Okay, let's write this in code. All right, let's see. So first, we have to write our function header. So it's a void, and because this is in a class, we first put the class name array. So array into list. We give it the name, which is stretch. Okay, so we first put array list. That's the header. First thing we do, check if k is empty. If k is less than 0, in which case we want to empty the list. Now, some students, what they do is they reset the size of the array. They make sure everything is blank. But in reality, we don't have to do that, right? The only thing we have to do is we have to just specifically say, oh, my size, set that to 0. Because once you set the size equal to 0, if you look at the later operations like add, right? They first check if size is 0, or if they're trying to add elements, they add it at whatever size is. So if you just set size equal to 0, we're saying, okay, everything else is garbage. Treat those as garbage and just pretend that the size is 0. So we can certainly do that. Okay? Let's see. Okay. Otherwise, we want to check if the array is too small. We know it's too small if after we expand it, the size is not enough, right? So we know that if the capacity But the capacity is too small. So too small would be if it's less than my size, so the original size, times how many elements you have to stretch it by, right? So here, if our size was 4 and we want to stretch it by 3, 8 is too small, so we have to resize it. If capacity was like 12, then we could resize it with that. We could stretch the elements without resizing. So that's why we want to do this check over here. Okay? If it is, then you want to declare a new array. So we want to create a new array. We do that by doing int star. Let's call it bigger. That's equal to, we create a new array calling new, and you have to give it the new size. The new size should be k times my size. Okay, this thing is optional. This thing just clears the array for you. You can or you don't have to do it. All right, after you create the new array, now we want to copy all the elements over. So we do something like for int. So we're dealing with arrays, so we can't use a for each loop, but we can do something like. Okay, and then here we just set the new array at index I, set that to the old array element at index I. Okay. Next, we have to delete the old array. So delete. We want to free the memory of the old array. So delete that bigger. No, not bigger. Bigger is the array we want. Delete elements. Okay. Here's a common misconception, which is when you call delete elements, you can't use the elements pointer anymore. Okay. But in reality, you actually can, because elements is a pointer to some array. Bigger is also a pointer to some array. All right. We want elements to point to this new one. Before we can do this, we have to first say, okay, elements, let's free this. Let's free this memory. Then after you do that, then you can switch elements to point to that one. Okay? You can still use elements. Elements is still a variable that you can use, but the memory it's pointing to is not used anymore. Okay? All right, so delete elements, that is essentially saying, okay, don't use those anymore. And now we can just say, now change elements to point to bigger. Okay? You don't want to delete bigger, because if you delete bigger, that will delete this array that element is pointing to. Okay, let's see. All right, now we have just modify, and we switch the pointers. We have to make sure that our elements is the same. So, our new capacity is now k times my size. Okay? All right. And then we can just copy this code over here. That's the code to switch the elements. I'm just going to quickly write it out here. For int I equals my size minus 1, I greater than 0, I minus minus. So this starts from the back of the array, and we're just going to copy the elements k times into the right location. So int j equals 0, j less than k, j plus plus. These are semicolons, these are j's. Elements at I times k plus j. We want to set that equal to elements at I. So what this is doing is it's saying, okay, set, what's the pseudocode? Our pseudocode was copy the array at index I to I times k plus j. Here we're saying, okay, elements at I, we're going to copy that to I times k plus j. All right? We're going to do something really similar to this on assignment 5. So make sure you take a look at that, okay? All right, assignment 5 is long, and debugging takes longer than coding. So get started on it early. This is one of the parts that you'll have to handle. Okay, thanks for coming, or thanks for not coming. See you next week, hopefully. Have a good week.